So welcome to this session about external domain context and how, in this particular case with Ktor and other utilities, we can maybe try to make our tests a little bit more expressive and resilient. So my name is Mykola. I worked at iptQ. It's an insurance company based in Switzerland, but we have a development hub at Hofdorp, lots of Kotlin, all the backend is Kotlin, just mentioning. Before that, I worked at bol.com. Yay! At TomTom, was also lots of fun. And before that, I came from Ukraine, so I would like to mention one thing. There is a vote going, as far as I understand, for where to donate the money earned in this event. So there are lots of good options. They're all good. But I work with people who founded this stichting, this foundation. They buy ambulances and send directly to Ukrainian cities where they're quite needed. So if you haven't yet made your mind, this is a good option. Just saying. Yes, with this, back to my story. So I myself, a backend developer, mostly focusing on the backend. And I am very interested, well, except for backend, what I'm usually looking at and what I'm focusing on is the continuous delivery. Because I think that's one of the important aspects of our work, to get things through much faster as possible, to get the feedback reliable with the high quality standards. And inevitably, that means that testing is often becomes a kind of a bottleneck or a question where the lots of frictions arise. Where we test, how do we ensure our quality, things like that. And that's why I am often working in this area, pondering, tinkering, seeing how to do our process better in that area. The last on the last Kotlin Dev Day, I made a small presentation about how Kotlin helps us to write more expressive tests with the help of syntax sugar, like mostly, in particular, the DSLs, type-safe builders. They help a lot. And other features like infix operations and so on. Today, I would like to go a little bit further, maybe in adjusting direction, and talk about the situation when we want to test our clicker and it doesn't work. Oh yes, something worked. So let's say we have an application, a backend application. It has some interfaces. It has some messaging, maybe queues that coming in, and has some logic. Maybe it's hexagonal, maybe it's not. There are different things that can be happening. It has its persistence. It has some other applications where most probably, even when working with monoliths, we'll have something else. But even more interesting when we're working, well, more relevant to me, at least in my recent engagements, is when we're working in the microservice environments. There will be lots of other services. We'll need to listen to events from or get the data, send commands, and so on. They will be interacting with us. They will be sending something to our queues. And how do we test these interactions? Well, there are obviously many different approaches. You can take a pyramid of testing, a very nice concept, and place the testing of those interactions in very different places. The first thing that comes into mind, contract tests. They're kind of, from the point of isolation view, very close to unit tests because they're focusing on the interaction details. Of course, with the setup, they're usually not seen as unit tests. But that's one of those. You can also test those interactions by deploying your code somewhere on staging environments, on production maybe even. I don't like deploying to staging environments to test. Sometimes we have to. I do like to deploy to production and test it there. But usually, my stakeholders are not very happy if the first testing really happens there. So, because I don't like working on staging, I prefer to have some more higher level tests also in isolation. That means when the tests are running in continuous integration, for example. And the nice thing about this whole model with this concept of testing pyramid, it's not really prescriptive. You can put different things depending on your situation. If we're talking about microservices API, probably there will not be many UI testing in the testing pyramid, but there will still be a testing pyramid with maybe end-to-end tests, component end-to-end tests in isolation, maybe on the environment. On the very top, some integration, more focused test, but still not as fine-grained as unit. In the middle, and the unit test. And the most important for me from this pyramid is that it's a pyramid. It's not like only the bottom layer, which hints us that we cannot really, or we can try, and sometimes it might work, but if we Google zero integration tests, that will know that we do want to have some tests in the middle that will be showing how our system working a little bit more holistically than just individual pieces of implementation, individual units. And that's where I would like to look how to write those tests. And I see when I work with the code, when I go to projects, I often see tests in that middle layer in isolation. And it makes me happy because there is usually the most value if something is working strangely or unexpected, or you don't know how the things are working together. But it also often makes me a little bit sad because there is lots of repetitions. They tend to be very tedious, especially when we start to have different interactions with different services in the same piece of code. And it may, these tests are fragile and difficult to maintain. So I would like to have something that is more focused, that is less fragile. Something like this, where an example I will be trying to build with you, where my test is focusing only on what is necessary. It doesn't really, it doesn't have too much of extra noise, and it is resilient to a change. So let's see with the code how can we do this, which is especially important when we find ourselves in the microservice environments with a big number of the nodes, because that's where I see this, the number of interaction can be growing very, very fast, depending on the architecture, depending on the setup or composition of the teams. Sometimes some microservices have to work with lots of data that is quite fragmented. A piece of data is here, a piece is there. There are different views of the same information, but coming from either different teams or different processes or whatever. And with this, I will show my code. Oh. Yeah, so this small demo that I composed, I will be showing a very simple example where I have some virtual platform for selling stuff, and there are products, there are suppliers, and these suppliers make these offers. So we're working with replenishment of our stock or someone else's stock. Are there any questions so far? Well, I will use this moment to refill my water. So, before I proceed, I would like to know who here is a backend developer. Oh, okay, thank you. And who is using still Spring? Okay. I'm in the right audience. For those who don't use Spring, there will be lots of pieces of example with Spring about setup and wiring in. I apologize for that. I will try not to focus too much on those things. So, okay, so how do we get to something useful and convenient? So we said that when we're starting to mocking is a good technique. Mocking allows us to go very fast, to write very focused tests. In the test itself, we know what we're mocking, what we're expecting from the responses of our collaborators. But the problem starts to be when we go to the higher levels of abstraction, when we want to focus more on functionality, and then repetitive given when then for small interactions that are not important for the test, they start to add some noise. So there are a couple of ways to deal with this. The one which I will show is not the only one. So you can refactor so that you collect data up front and only pass the data. You don't call external services, for example. But a common approach is one of the approaches is replace the mocks, the things that only replay what it's told for them to do, with a fake implementations, which has a little logic. For example, here I am saying that I have a fake for product microservice, and I say that it has a product. So it will register its product, and it will know that whenever it's coming to it and asks by its ID of this product, we will find it in our in-memory store or whichever we're using to keep the data and respond with this. If we're searching for title, we don't need to code this again explicitly like we do with mocks. We know that, okay, there is a simple implementation, we have a title, we have a simple filter, and we return everything that matches this particular call. So something very simple. It can be implemented as in memory. It can obviously be implemented as in memory. It can be implemented as a stub of something that we have in our system. For example, here in this very simple example, I have a concept of seller, and I have a seller repository, a thing that gives me those sellers fetches by ID from external system. So I could have just made another implementation, extracted the interface and made another implementation of this seller repository, and for the testing purposes would fetch those sellers not from external system, but from our in-memory structure. That's a perfectly valid approach. I personally prefer, for historical reasons, to go a little bit further. So I try to build the tests against the systems that are as close as possible to production setup, well, when it makes sense. So that's why often I would go and build an HTTP fake that would be returning me what I expect. How I'm doing it now. So I will be using only one repository. I will not be changing it ever. It will be the same as it's used on production all the way. And the only thing that will be changing is the URL, which will point, in my case, to a fake. So if I go to seller, I will create a small fake. It can grow, and if there are lots of functionalities, that's a downside, but for simple cases, it can be relatively simple. And I can build it with any tool, any framework that I want. In this example, I am using Spring, for example. I could have built with a Spring, also added some controllers and expose the test data. Sometimes it's not very convenient because of the complex setup of especially all the projects with security, Spring security and stuff, so it's easier to have something more controlled running manually in the test. So I like recently to use Ktor because it allows me also to play with Ktor. I'm not usually using it on production code for various reasons. So it just starts a new server, does some simple initial features that allows troubleshooting and debugging, and does the beautiful things of Ktor. It says when there will be a call to seller with this ID, let's look into our registered sellers, and if there is something that we know, let's just return it as an HTTP response. Here, a small but important part is that what we are returning over the wire is not necessarily what we want to see in our code. To demonstrate this, I have slight adjustments to the DTOs, so that in our domain, we're using a seller with, for example, ID and name, but in the systems that we're talking, for whatever reason, they're using a different nomenclature, different namings, and they have seller identifier and company name. So it's good to build our tests, the functional test, in our language, in our domain, how it's more convenient to us, and have the translations on the edges. Any questions so far? Yes?
I see when you fake the response with Ktor, you are returning the object. Can you also return the pure JSON so it will go through the parser?
Yes, you can. Well, first of all, I'm returning object is serialized to JSON. So what so it's not shortcut. So it will not be received as JSON as object on the receiving side. It will be still JSON.
Oh, okay.
It's not very obvious, but yeah, that's how it works basically. It's bypassing the shortcuts. The idea is that this is a normal HTTP server. I could even expose, and I saw some setups where people on test environments, on static environments would deploy these things. They will expose, and then you can test something without going to other systems, like with UI, for example. Right, so this is a simple fake, and usually when I'm writing such fakes, it's good to have a test for the fake to make sure that what we use is behaving as we expect. Again, another downside, and very valid, that we're adding some code. That means it's a little bit of extra complexity. It can be tested on its own. So it's not for very, very trivial interactions where it might be an overhead. But the good thing is that often these tests can also be reused against the real systems, and you can have a pair of kind of functional or sort of contract test, not a really modern way of contract, but something that you can run against an external system, and the same code you can run against your fake and basically check that they're both running in the same way and fulfilling your expectations from them. Usually for the fakes, you would have some kind of backdoor to pre-configure it, that we will have some kind of state that will be useful for us. In this case, we are saying, okay, given a seller, I would like to be able to fetch it by ID. And a small but important thing for Spring, to make it work with the same, without having multiple Spring contexts. If I want to have a dynamic port, I need to override the base URL that will be used by my normal repository. A technique that I find useful for that is to introduce a special bin, a special class for every dependency so that they don't overlap with each other. It's Spring specific. And say that in production code, we introduce this URL based on the configuration, which will be injected by property files or from environment somewhere. Whereas in test, we have another configuration that is always fired up or whenever we want to, which also defines the same bin, but overrides it as primary. And in this case, it gets the URL from the fake server that started with the dynamic port, especially when we're running on some environments where there is not a very good isolation in some Jenkins setups or on local systems. It can be quite convenient. But okay, so this is basic anatomy of these fakes. It's okay. It's a little bit more convenient sometimes, but it's still not perfect. If I go with tests, I say I want to test some functionality that depends on different calls and related data. I need to do myself the links between the data. I say, okay, this offer belongs to this product. I need to say it explicitly. This offer belongs to this seller. I need to say this explicitly. A little bit too much of a hassle. And that's where the idea of defining a context for your tests, either in general for the application or some isolated areas, the way you see it fit for your particular case comes in play. So we can say, okay, our main entity we're working in this test or in our application is the offer. So let's define a higher level abstraction, an offer, which, so instead of saying explicitly separately, we have a product, we have a seller, and we have an offer, we will bound them together. It can be simple descriptions. You can have a separate DTOs defining, okay, these are the specification, how I want my data to work. But with the builders and the DSL feature of Kotlin, which I always forget how it's called, receivers type, some other receivers, it becomes quite convenient to have this set up because you can reuse these kind of builders for your test data in different contexts. I could use it when I'm saving something. I could use it when I'm just creating an object for my unit test. And I can also reuse it in this more high level builder. I will say that, okay, I will have a product adjuster for my offer. By default, it will not be adjusting anything, so I will be just using the default product as it is. But if I want, I can override it because I want to have some other functionality. And here I will say, okay, I want for this particular test offer where the product will be with this title, the offer will be like this. And I will run my tests, and they will be green. And if I want to change something, I can also say, for the seller, I will have trustworthy. Trust is not trustworthy. Seller, for example, of the offer, which is cheaper, and it will not be available anymore. With not a very nice error message, but okay, good enough for now. So this is basically the idea. In Spring, again coming back to Spring, the way it works is I usually define a component which has direct calls, which has links to the fakes, and the test will be going via this component, which is always available in the test Spring context with much less dependencies. And how much time do I have? 5 minutes. I'm going good. Yes. Okay. So the huge benefit of this is that the tests are much more resilient to a change. If in my logic somewhere I change the way how I traverse the data, for example, I don't have to change anything in the test setup because the data already defined. The data says we have offer. These are the relations to the other entities. If we, instead of going from one side and searching for something else, we're starting to go from another side, technically nothing is changing. If we need to split out the data, if we say that product now comes combined from different services, the VAT comes from other service, or some product description is coming from other services. For tests, it doesn't really matter those which are using this high-level concept. We can build it into our definition of this context. It's a little bit similar in a sense to how hexagonal model defines the domain for itself and then adapts everything. But from the other side, it's kind of a reflection. What is the rest of the world to us? What's important? And before I come to the conclusion, any question? So, this approach with dynamic data, with detached from the details of the implementation, we care less about how it is spread out across our landscape. We are more focusing what is essential for our test. It's obviously less noisy. We have less connections, less details to maintain in our tests. It's more consistent. One of the biggest grinch for me with mocked tests, be it HTTP mock, wire mock, or just Mockito, is that you have you can easily code responses that will be inconsistent with the real situation. This usually doesn't happen with the fakes if you code them properly. They're resilient to change. They are documenting a little bit better what your expectations from a system. It's localized in the fake implementation. You say, this is what I want, what I expect, what I rely upon from other systems in my functional logic. And in the example I showed, it also allows me to play with other libraries and framework before I promote them to production code. And with that, you have a question? Yay.
All right, so you now display how you can use this kind of builder pattern to make it clearer to work with external dependencies. Wouldn't it make sense to also do something for setting up states, your own state, if that's slightly complex?
Yes. Yes.
And would you do that in the same kind of context, or would you keep that separate?
Well, historically I do it in the same big thing, but it would make sense to keep them separate, especially if the amount of entities there is growing. And especially when I'm thinking about this talk, then yes, I would keep them separately. In usually I have them all together as question to something.
Nice, cool.
Okay, then if anyone interested in the details of the implementation, it's in this very short link. I'm always accessible via this Twitter handle.
I have a question still, if it's possible.
Yeah? That's good.
Okay. So basically what I see is that you're making your basically your test cases a bit more involved. Like not like WireMock is very simple, right? Or not WireMock, but like Mockito, for example, you just have one variable, etc. And now, but do you not need like now to test your test basically, or basically test your the web server you have behind it? Because you're actually, it's an implementation, right? So
when I'm doing these implementations, I did show one test already that was testing actually the fake server. So saying, okay, when I put something via the backdoor, I expect when I will get the same, serialized back, but equals entity. I can also check, basically I would be testing all the interactions that I'm doing, the same TDD. It's the proper code with upside and downside of that. Plus, usually, I would also have, where these things are working to replace external dependency, you want also to check that on the more low level, the external dependency, our assumptions, how we work with them are correct. So you would probably want to have some kind of contract tests, maybe, or maybe some low-level WireMock tests, or some tests where you say, okay, this is precisely the JSON, this is precisely the exception, because you don't want to model them in the fake, otherwise it will be too big with exceptions.
Okay, thank you.
All right, give it up one more time for Mykola.